diagrams for compounds. So I have the step-by-step on one side. I'm going to do some examples for you on the other, but let's walk through the steps. So the first one says determine the total number of valence electrons to be shown in the diagram. So for water, for example, we know that hydrogen has 1 valence electron, and we have 2 of them, and oxygen has 6. So in my water diagram, I should have 8 total electrons. Now, carbon dioxide, carbon has 4. Oxygen, like I just said above, has 6. We have 2 oxygens, so in total there would be 16 in that diagram. Move over to nitrogen. Nitrogen has 5 valence electrons because it's in group 15. If there's 2 nitrogens, we should have 10 total. Now, SO4 -2 is the sulfate ion. So if I look over at step 2, it says if you are diagramming a polyatomic ion, we add or subtract the missing or extra electrons from the total count according to the charge. So for SO4, sulfur has 6 valence electrons. Oxygen also has 6, and we have 4 of them. And then because this is a -2, that means there's 2 extra electrons. This ion has gained 2 electrons, so we're going to add 2 more, meaning in total for this diagram we would have 32 electrons. Okay. Now determine which atom goes in the middle and arrange in a cross shape / imaginary squares. So the central atom is the one that there's the least of. Hydrogen is never in the middle. Hydrogen only has 1 valence electron, so it can only form 1 bond. You can't put it in the middle. Halogens are almost never in the middle because they have 7 valence electrons. They only want to form 1 bond as well. And if carbon is in the compound, carbon is always going to be in the middle. And if there's more than 1 carbon atom in the formula, it is bonded to itself in a chain. So we'll do one of those examples together in class at a later date. So for water, oxygen is going to go in the center, and we're going to put hydrogens on the side of it. Then it says, draw each atom with 8 electrons, except for hydrogen, it only wants 2. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8 electrons around oxygen, and then 2 on each of my hydrogens. Now, remember when we're putting electrons around an atom, they make like a little square, whereas my hydrogen, I put them on this piece just because we're going to be connecting them to the oxygen. Now, connect a pair between the atoms and erase a pair between the same 2. So if I connect this from oxygen to hydrogen, I'm then going to erase 1 from oxygen and hydrogen on this side. And then I'm also going to connect a pair from hydrogen to oxygen on this side and erase a pair. I want everything to be attached to the central atom, whatever one is in the middle. Okay? Now recount the electrons. So I have 2, 4, 6, 8. That means I have the correct number. So I don't have too many. Then check that all atoms have an octet. So like I just said, oxygen, we have 2, 4, 6, 8. So oxygen has the octet. Hydrogen only wants 2. 1, 2 are with the hydrogen, and 1, 2 are on the other side. So that would be my diagram for water. Now let's look at CO2. So carbon's in the compound, which means carbon's going to be in the center. And I'm going to draw the oxygens on either side. So I'm going to put 8 electrons around my carbon and 8 around each of my oxygens. Okay. So connect a pair between the atoms and erase a pair between the same 2. So I'm going to connect this carbon to this oxygen, and then I'm going to erase this pair. Do the same thing on the other side, and erase the pair underneath. So now we're going to recount the electrons to see if we have 16. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Uh-oh, that means we have too many. So it says connect and erase another pair. So I'm going to pick to do this one with this one. Okay, we always want to make sure we're connecting to the central atom. We wouldn't want to make a bond between the two oxygens. All right, so now we're down to 2, 4, 6, 8, 10, 12, 14, 16, 18. So then I'm going to connect on the other side. Now, it doesn't matter if I did the bottom on this side and the top on this side. What's important is I have two bonds on both sides. So now we're going to count it out. 2, 4, 6, 8, 10, 12, 14, 16. So my total number is correct. I got to make sure that all atoms have an octet. Okay, so 2, 4, 6, 8. Oxygen's all set. 2, 4, 6, 8. Carbon's all set. And 2, 4, 6, 8. This oxygen is all set as well. All right, now we're going to move over to the SO4. So sulfur is going to go in the center with the 4 oxygens around it. And again, we start with 8 around each atom. Now this might seem a little tedious. You know you're going to be erasing some, so why are we drawing each of them with 8 to start? I like to draw each with 8 to start so that in the end we are guaranteed that everything has an octet. So I'm going to connect a pair and erase a pair all the way around. Make sure each oxygen is bonded to the sulfur. I connect and I erase all the way around. And then we count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That's the correct number. Okay. Oxygen has 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And sulfur has 2, 4, 6, 8. And last but not least, when you have a polyatomic ion, so that's any group of atoms that have a charge, you need to put the Lewis dot structure in brackets with the charge on the outside. That lets me know that overall this has a charge of -2. And let's do this last example together. So I have nitrogens bonded together. So I'm just going to put them side by side. There is no central atom in this case because there's only 2. So we connect and we erase. So 2, 4, 6, 8, 10, 12, 14. We still have 4 electrons too many. So then I'm going to connect this pair on the bottom. Now I'm at 12. I'm going to connect one more pair up top. And we have 2, 4, 6, 8, 10. And each nitrogen has 2, 4, 6, 8. 2, 4, 6, 8. So each of those has the octet that it wants. Okay? So I want you to try these on the bottom of your paper and see how you do.